Welcome to the Innovators Insider Podcast. I'm Richard Doyle, the user group guy, here with my co-host, Michael LaFleche, the professor. How are you today, Michael?
I am very, very good, Richard. It's a beautiful fall day, here in the Boston area. The wind is blowing, the leaves are on the ground. Feels like pumpkin season.
Well, we're starting to get a little taste of that. It was 61 degrees when I got up this morning. I had to fight every urge I had to turn on my heater in my little apartment here today, but I managed to skate through because I knew it was going to be 88 degrees by noon. So, we've got those weird temperature swings here in fall in Las Vegas. It's kind of interesting. So
Totally.
Yep. So we've got a pretty good show today. Episode number 30. It seems like we just started. Yeah, just started this thing, and we've already dropped 30. This will be our 30th episode now. All about the new Onshape Simulation, and we had a lot of scheduling issues this week. A lot of folks that are really busy. So Michael actually did the interview with Greg Brown, and we're going to go ahead and show you folks that right now.
Welcome back to the show. Greg Brown, head of product here at Onshape, longtime PTC person and longtime simulation person, which is what we're going to be talking about here today. Onshape Simulation, unless you've been living under a rock, right? You've probably seen the announcements, heard about it. You may even tried it already. So first of all, welcome back to the show. And I'd love to learn a little bit more about why we decided to jump into the world of simulation.
Sure. Well, thanks for having me back. I had a great time last time, and I'm really looking forward to sharing what we've been doing. There's a bit of a long backstory to it, really. And this whole topic of simulation as part of a designer's sort of tool set, right? And that's the essence of the story here, to give designers who are using Onshape something that they can use to help support decisions, like they're about to do something, create a shell thickness or add a rib. And while they're doing that, that's the time to get some feedback saying, well, do we actually need this rib, right? Or how thick should this approximately be?
Right.
So those kinds of, that's the kind of decision support that designers really need as part of the process.
Right. Yeah. I mean, Onshape is all about being agile and iterating, right, on products. So the more you can iterate, the more information that you can have at your fingertips, heads up, right, will be extremely beneficial. And I've been noticing that already, in using the product. It's really helping me personally just, understand what's going on, right? That's really what it's all about. But I think it might be interesting, to the viewers and the listeners to kind of, understand, not only the product, but, the person, the people, behind the product, right? I think that's something that I always find enthralling and entertaining. And there's so many stories that come out of this. So I would love for you to kind of share with the audience how the heck you got in to simulation. And, it's pretty propeller head stuff if you're really under the head, right? Under the hood. So.
Yeah, I mean, well, if you go all the way back, I studied mechanical engineering, and in my, I was also sort of minoring in math, and computational analysis was a really big part of that applied maths that I was doing. And actually, I was initially interested in CFD. So, I was, after I graduated and had done some stuff post-grad, I actually started a company with some friends, like-minded friends, very much propeller-headed, like-minded friends, doing CFD consulting. And we found that there was a real opportunity at that time to go more into the structural analysis side of things. And, using tools at that time, they were Nastran-based tools that I was using. Mm-hmm. And there was a consulting company who was using this software called Pro Engineer at the time, right? That we started doing a lot of work with these other consultants, these CAD consultants. And as part of that, I found that there was a better tool to use, and that was RASNA Applied Mechanica. So I became a RASNA Applied Mechanica user. And, fast forwarding a little bit, at the first conference that PTC, when they came to Australia, by the way, this is all happening in Australia for me. Okay. When PTC came to Australia to set up an office, basically my job interview was when I was presenting on the benefits of applied mechanica, or RASNA applied mechanica, as something that you could use early in the design process for early insight and analysis. So even back then, there was an understanding that the earlier in the process that you could do upfront simulation, the more actionable decisions you could make before things got too expensive to make changes. So this is like going back 20-something plus years. So why are we talking about it again, in the year 2022? And it's an interesting, that's where the story really kicks in, because over that 25-year period of time, I've been teaching, using, consulting, helping develop simulation tools in a variety of different places. And it's been great, and the tools are great, and the industry is really, really compelling and interesting. But there's still just been something missing for pure designers and true designers in their early parts of their design process. And that's something that we, a little while ago, saw as an opportunity for Onshape to really sink its teeth into and deliver for the first time.
Yeah, it now that I'm kind of thinking about it, as you tell the story, it makes total sense to bring this type of simulation, to the fingertips of people using the system. First of all, running simulation, right? It usually takes a pretty expensive computer, well-spec'd machine, that's purpose built typically and runs, for a while when you're running the simulation. Onshape is a cloud native product, right? So, if we could offload some of this computation and, not have your computer melt through your desk, that's a benefit.
I mean, it was always the lucky couple of people, or just one person in the office, who could get the big machine that had, like 384 megabytes of RAM at the time. That was a huge machine, and, the big Silicon graphics workstation with the extra graphics card. And that was allocated to the person running simulations. And that was one of the huge barriers of entry, even though the software was trying to be pitched to early, the design community. It's just, there was no way of affording it. And to wind you back a little bit, I like to think of FEA as meaning fast, easy, and accurate, right? Those three, and over those 25, let's focus on that 25-year period, because that's what I'm most familiar with. But people generally made a choice of 2 out of the 3, right? You could have fast and accurate, but it was definitely not easy to use, or easy and accurate, but definitely not fast to use, right? And or some other of those combinations. And because of that, it really stopped that was one of the big barriers of adoption. But there's this other real big barrier, and that hasn't been addressed over the years. And I think that this is the main thing that we have focused on in our product, to make it meaningful, and to take what designers are seeing in front of them, the work that they've already done, and take meaning from it, or take the context for the simulation from the work that's already been done in the assembly.
Right, exactly. In many systems, you have to do the work twice, right? You set up your mates to set up your assembly so it works and moves the right way, and you have your accurate count and the bill of materials, but then you have to go through and do the whole setup again, when you start, setting it up for analysis. And that insult to injury, you're probably simplifying the model, making it symmetric, things like that too. So
actually, that's an interesting point. That's one of the other big barriers I've seen over the years. People aiming at the design community is one thing, but then saying you have to understand these abstractions, which are coming from the 50s and the 60s kind of Nastran speak. That's great. Nastran and all those tools like it are fantastic tools. You just have to be an FEA specialist to really understand, the meaning and the implications of what you're doing with that symmetry. So taking away the need to do those kinds of abstractions and to understand the physical implementation, or the physical inferences that you've made, and that you understand as a designer with the assembly, is key to this whole thing.
Exactly. Maybe we should take a peek at it, and we can talk about some of the stuff relating to simulation as we share screens here. So I'm gonna add a design, an Onshape drawing here to the screen. It's a caliper bracket.
Yep.
And, I have a drawing of it here. Let's go to the assembly, right? And Onshape assemblies are essentially Onshape simulation, right? It's
That's true. Actually, I'm going to jump in and say, many times, Onshape simulation is Onshape. It's not a separate environment. Mike, you haven't got a different element that you've added here. There's no different tabs or environment. It's just Onshape, right? It's assembly.
Yeah, I didn't have to go in, add in or anything like that. But I am in my assembly. We have mates and relationships in here. We have an axle. We have mounting. We have all our hardware, and that's how you would build it if you were building this as a subassembly.
So yeah, I mean, you already know how to use it. Right? This is Onshape. Yeah.
There's a few more buttons now, though, right? We got a few buttons over here across the top to apply your forces. Of course, you need to tell it how what's acting on it. We also have a little tab over here too that will give us some interesting information. But I'm actually just gonna show the results first. We've already this one's already been set up. The only thing we had to do was make sure that materials were applied.
Yep.
The forces were applied, and that we've set it to be in a static state. When the simulation starts, so you just need to make sure that if you did have moving components, that they're not moving for the moment you're running the simulation.
Yeah, so a couple of things there. This is linear static analysis, as you say, and with the word static being a keyword there, I mean, you can't have things flopping around. And interestingly, because Onshape simulation is Onshape, it's utilizing and benefiting from some of the, in this case, new features, such as showing in the assembly tree what things are fixed, and whether the assembly is free floating or fully defined. And in this case, we can see there. But no, you got some nice results up there now.
Yeah, I mean, I don't know how many seconds it took. I wasn't looking at my watch, but it was done halfway through us talking about the interface.
So yeah, I mean, we like to talk this as interactive time, right? Real time would be a bit of a stretch. That's not a realistic way to describe how things work. Real time is real time, but interactive time is not even time for us to finish that sentence, right? Or get a sip of coffee. I can start making decisions based on what I'm seeing here, without having to wait and without losing the flow of what I was thinking for this design.
Right. So this is here upfront design simulation, works with all the things that you would think of using Onshape for, right? So of course, I'm doing a design for manufacturability study right now. On this is just the normal Onshape way of exploring design iterations, right?
Yeah.
And
sure.
I'm looking at this corner. It's looking a little sharp here. Maybe we would have a rounded corner here. See what happens to the stresses in that region. Perhaps might be an interesting way of.
How about the displacements? Before you go into that, how about looking at displacements? Yep.
Yeah, let's take a look. Yeah. So here's displacement. I can hover over this here. It's obviously not moving there too much, but of course we're seeing some movement here, right?
Oh, yeah.
You can see that. Yeah.
I mean, one of the first things you do, I mean, even if it takes 5 seconds or 10 seconds, the first thing you should do is animate this, the displacement and see if things look reasonable. Right? As a designer, I've got some intuition that I'm expected to apply to this, so I can see that if things are moving in the wrong direction, I've probably put the load in the wrong direction or something else. And then by the time you've sort of verified that you've set this up properly, the results are done, and we can have a look at some other things.
Exactly. I'm going to hide the shaft here so we can see what's going on around here. Let's, we can see all sorts of different quantities.
Sure.
All the Onshape viewing modes will work here. So you can
actually, while you're there, I mean, that's an interesting thing. The simulation results are part of the tree, a part of the view modes against like shaded modes, shaded with no edges, hidden lines displayed. So. And draft angle analysis and curvature visualization for zebra stripes, those sorts of things. We want to put visualizing the simulation on that same level. Like I make decisions based on what I see with hidden lines. I make decisions based on what I see with the draft angle analysis, but I'm also making decisions based on things like this. So it just seamlessly goes into, like you're showing now, all the rest of my normal workflows in Onshape: exploded views, section views. What are you looking at there? Oh, variables, right? Yeah. Okay. So everything that works just works, right?
Yep, exactly. This is the part that really made me kind of sit up and think a little bit, though. People in Onshape work together because they can, right? And it's a fast, iterative design. You need to be able to work together, collaborate. But this is my phone, right? I'm on my phone, and I'm going to go to the to the actual part studio, right, where design changes will take place, right? So I'll just go in here and pay close attention to the simulation screen, right? Because we have results, right? Everything is as it is at the moment, but I'm in a let me actually work properly parametrically here. There's a chamfer going around this. Let's just roll to here, so that way we have that, and then I'm going to stick a fillet right here. Then I'll just roll to the end, right? But all this is happening, right, on my part studio while I'm doing the part design, design for manufacturability. And then, the person, it could be a different person, same person. You might just do this on your own computer, but
no, forget it. We want to do this together, right? So yeah. You've called your expert, you've called your lifeline, right? And
exactly.
Yeah, they're suggesting what they're.
I like that. Yeah, let's call, put out a lifeline. Somebody says, put a fillet here. Let's see what happens. And then, voila, right? We have the simulation results. And I didn't touch one button as the person looking at the simulation. I didn't hit anything, right?
Exactly. I mean, just in the same way, you didn't have to ask Onshape to reshade or retessellate or recompute the hidden lines. Like, you didn't have to do that. The same way you don't have to ask it to redo the simulation. So.
Right. It almost feels like, back in the old days when, we're on like, what is it, Pro E version 12? I don't even remember. But like, I'm thinking of AutoCAD. Like, you actually had to physically type in the shade command to actually get a shaded image on your screen. And it was like, you couldn't work interactive like that. And this feels like we've gone from like black and white TV to HD color with
That's
this
right.
kind of way of thinking about, the simulation and how it's interacting.
No, yeah, it's phenomenal.
Yeah. So we have stresses. We have factor of safety is another one, a good one here. So brings up a good opportunity to show the simulation panel.
Yeah.
And I'll just hide the phone over here. That was just my parlor trick for the show here. But here we have different types of looking at things. Sometimes like a red and blue type plot looks good for factor of safety type plots, I would say. So obviously we're in good shape here. We're seeing.
While you're talking about factor of safety, we're getting that from the material properties, right? And so materials are assigned in the same way they always have been, which is in the part studio. You assign a material to a part. And we've enhanced that, obviously, for simulation. We need some more properties. Previously, it was really just the name and the density, but now it's Poisson's ratio, Young's modulus, the yield stress, the limit stress, those types of things. So because we know, the yield stress, that's how we're calculating the factor of safety for that plot that you're looking at there. So no extra effort. It's meaningful for a designer.
Exactly. Yeah. All right. And of course, I've noticed some small things too. You can, move these things around if things are in the way, and look at it in different ways. Another thing that I've been liking with this, if I pull up a stress plot, set this to another color, you can totally use the comments and markup tools, to point things out, right? And I could, say to my colleague Debbie or something, take a look at this, right? Assign that as a task, whatever it might be, right? So very easy to have these design communication kind of things. We could probably do a whole session on like, how I've seen sessions, how in other systems out there, like how to manage the results files and how to, check them in the PDM so that other people can take advantage of this data and use it. Like
This is the trick of the platform now, right? Because all of that is built in.
Exactly. Right.
It's built in, and in fact, there's one of my the comments and the other things you've been showing in there. The bills of material also work. Obviously the materials are integrated with what you had with the Part Studio, but there's something else that we released last week with the latest release of Onshape, which is publications. And publications are a really, really interesting way. And I don't know if this is the first time you've seen this, but you can create a publication where you're really sharing the assembly, which is the thing that you've just been simulating. Everything you simulate is an assembly. We figured that that's the real context for all the simulations. It is the assembly or an assembly that you create in Onshape. So, what you're doing there, Mike, is you're just grabbing a reference to to that assembly, which is a versioned reference. So as you publish this to other people, a publication is kind of like as a new class of as a special kind of document, really. It can be shared. It can be, you can limit the share to view or other people can edit it. But really in here is the idea is you can put a number of different, there we go, Debbie gets another, oh no, someone else. It's another chance to have view-only access. And of course, if you have the capability to turn this on, you can show the results, you can do the animation, but now you're still just in a view-only mode for this document. And you could therefore have perhaps V1, V2, V3, V4, V5, all very, sitting next to each other and flip between them really, really quickly. And that is a really, really cool workflow for in one publication, which is exactly why it's called a publication, to share that. I also, have started including supporting documentation. There might be like a PDF that was a part of a document or a Part Studio as well. So the publication contain a number of different things, and there you go.
Wow, this is great, Greg. This is mind-blowing stuff that I had not thought of until just now. This is fantastic, being able to stack these up, have comparative results right here ready to go. You have a nice notes section here, so you can add in markdown text, and even your Grammarly extensions will work with all of that stuff, right? So it's really good. Engineers are notorious for grammar errors, so that's why I make sure to really turned on.
I'd have to grab that myself. No, yeah, but as you said, if you flip back to that first, you've got the second one there. If you flip back to the first one now, if you just double click that, the results will come up really quickly because they're cached. They're cached in the cloud, and all of this is happening without heating up your desk. I imagine there's no meltdown occurring because all of this computation is in the cloud.
Yep, my computer's not taking off. The fans are not on full blast. They're not even making a peep. So yeah.
And if you when you share that publication to me or Debbie or whoever else, I can get to this kind of viewing point really, really quickly without there's nothing to be transferred. We're just pointing back to the same publication.
Yeah, that's great. Well, what a great power tip there. That was a surprise. So
there you go.
Yeah, thank you. Well, Greg, thank you so much for joining us to talk about a little bit of simulation here today. We're really excited about it. Can't wait to hear more stories from the listeners with your experience using it right now. It's in it's simulation beta label right now. So that means enterprise customers have access to it currently. So we're looking forward to roll that out as soon as possible for everybody else on the professional plan. I think we noted on the forum post. So we have a lot of this has been really great though, Greg.
No, happy to share some stories. There's plenty more, so I'll be happy to come back at any stage. So look forward to that too.
Awesome. Well, thanks again, Greg. Have a great day, and we'll see you around.
Okay, thanks very much.
What an impressive display that Greg was able to put on. Greg has got a lot of experience in simulation, right? You heard, this is like the early 90s. He was at Femrasna, and which was acquired by PTC, and he's been here. As soon as PTC acquired Onshape, Greg raised his hand
Yep,
up and
he
said,
ran.
I want to come to Onshape, you know. So that, you know, he's really one of our biggest fans. It's really awesome to have him as the head of product. He's got a lot of energy, funny guy, but really, I mean, obviously he's like extremely smart.
Yeah,
you know, I'm
absolutely.
really happy, you know, that he was able to come to the Onshape team and help drive.
And I think our viewers will probably appreciate the way he described Onshape Simulation and how it works and and why it's different and better than some of the other products. And I just absolutely love, finite element analysis is no more. Now it's fast, easy, and accurate. I just love that.
That's it. We finally can get there.
And it was great to get some of that bonus information out there about the new Onshape publications too.
That's right.
Yep,
That's
so
right. I mean,
think,
not often that somebody hits me out of left field like that. You know, it's a wonderful feeling to see something like that. Like, oh, something I didn't.
Yeah, we can talk about that too.
Yeah.
So you can get folks, you can get a whole lot more information about Onshape Simulation from a webinar that's going to actually happening next week. Greg and oh gosh, I forgot who else is
Chris Gromack.
Chris Gromack, yep, is helping him out with that. That's going to be Wednesday, October 26th. Starts at 1 p.m. Eastern time here in the U.S. And then there will be a second webinar for the following day, Thursday, October 27th at 1 p.m. Central European Summertime. And I checked, we do these things ahead of time, so I wanted to make sure that it was still summertime next week over in EMEA, and it is. So we'll put the events that you can go to the Onshape, onshape.com and go to the events page there, and you'll find both events. You can register for those there. So
exactly. Yeah. Don't miss it. I mean, this is like, you're going to get a lot of information out of this. It's going to be really good.
So we've got a couple of other things that we're gonna cover here on the show. We've got a model of the week this week, huh?
Yes. We were looking around for some really cool public models, and one of our people on my team, she was like, this is a really cool model, and she's actually new to CAD. Her name's Elena. We're going to have her in the show at some point in the future. She's a recent graduate from Texas Christian University, and she's into environmental studies, and she's done a great blog recently on sustainability. But she also has been learning CAD, learning Onshape, learning Render Studio, and was excited about the model of the week here. So let's put it up on the screen.
All right, and this is from Tony Soares. I think is how you pronounce that last name.
Yeah,
that's the Pearson Triton boat.
Yeah, it's beautiful, beautiful boat. Maybe someday I'll get myself a slip and a boat. Who knows? But this is beautiful, right? I mean, it's beautiful really shape. I mean, you notice some things about this, right, Richard?
The first thing I notice, and it's really funny because I find myself slacking off sometimes, but I really appreciate when somebody names their features and keeps a nice clean tree, so you always know what it is you're working on. Sketch 1, sketch 2, sketch 3. When I get lazy and I find myself, not naming my features and naming my sketches, you find yourself clicking to find the one sketch that you're looking for that you want to edit. So, good job, Tony. Keep it up. And, when you get to the assembly level, you might start considering naming some of your mates too, but that's just me. So.
Yeah. Well, there was only a few, so we'll give them a break.
Yeah.
Here are some of the renderings that Elena was able to add in. You can see
really nice
beautiful textures, and I was like, I challenged Elena. I was like, it's nice to see the boat out of the water, but what about in the water?
Yeah,
right. So
I saw that one too. Yep.
Come up with some different ways of putting different environments in. You can create a little wave pattern here and stick it in the water, and it makes for a much nicer display of the rendering. Let's just go back over here. All of these are really cool. To me, it just makes me feel good looking at this.
Yeah, that's a good one right there. I really I clicked through all of those renders this morning, and that was one of my favorites right there. So
yeah. So it's a great work.
Rough seas. It makes me seasick just looking at it.
But yeah, it's you're safe in Vegas, yeah.
Yep. I've got great land legs, no sea legs. So thanks, Tony, for that great work. And of course, the link to that public model will be in the show notes for everybody. So. So let's finish it up with one last thing. We're gonna be posting a couple of early podcast episodes. In fact, we're gonna be posting our next episode after this one. Will actually come out next Thursday, the 27th, because it's gonna be our Halloween themed episode. And we've created a little challenge, the Innovators Insider Halloween Challenge. And we're asking our users to go ahead and create some Halloween themed models. And we've got several categories. You can create a part studio, you can create an assembly, maybe do a render, or even a feature script. We've already got one good example of a feature script that's been posted in the forums. You can enter as many times as you'd like. We would appreciate it if all the models become public at one point, but I don't think we're gonna mandate that. And we will be either showing off some of our favorite models that we picked from the forums or inviting some of you folks to appear on the podcast with us. So if you want to get in on this challenge, you should be willing to appear on the podcast. We'll be recording next Tuesday, so the deadline for submissions is going to be Monday. I highly encourage you to take a look. We've got a couple of submissions already that are really nice. Let me go ahead and put those up on the screen.
A little inspiration here, yes. Oh, look at Michael Pasco's pumpkin there. That pumpkin has attitude.
It does, and the thing about this pumpkin is the model itself is used in a feature script along with some AR. I wouldn't do it justice by describing it, so I'm not going to. You can go to the forums and you can see what he's done with feature script. And the model on the right here, Brian LaGrange, the thing about this model is not only did he model it, they actually built this down at Medsco Fabrication down there in Louisiana where Brian works. So it's a real life object, not just a CAD model.
That thing is beautiful. I mean, it's great.
Yep. So those are a couple of the submissions already, and we look forward to seeing the rest of them and hopefully having some of you folks on the show. So.
All right, I'll bring my candy corn.
You know what? And I'm not going to give away what the costumes are, but I guarantee to our audience that Michael and I will be in full Halloween regalia. So you don't want to miss this episode.
You do not. Well, Richard, thanks again. What a great show. It was good to have Greg on, and the model of the week is always fun, and can't wait for Halloween time. This is going to be fun.
I can't either. It's just a week or so away, so we'll be getting there close. So.
Yeah.
Michael, great show. And as always, to our viewers, thank you for tuning in. Thank you for either watching or listening. Please give us a like and hit that subscribe button for us so you never miss an episode. And we'll see you next week for Halloween.
All right. See you.